Yeah. First of all, now let us see how to prove A union B is nothing but A intersection B. When this is true, if and only if A must be equals to B. If this is true, we can say that A union B must be equals to A intersection B. For proving this sake, what we need to do? We will be doing this in the first two steps, right? What is the first two steps here? First step will be you need to consider first statement is true. You need to prove the second statement. And what is the second one? You need to assume that second statement is true and you need to prove the first statement, right? So let us prove the first step. Okay, that is a step one. What we need to do? I already said that. What we need to assume? We need to assume that a union B must be equals to A intersection B. This is what we have assumed. Then what we need to prove? We need to prove that the second statement. What is that? A must be equals to B, right? So now let us see how to prove this. For proving this sake, what we will do? Now let us consider one element X is in the set. Instead of B, let us take with A. Okay, we will do the right way. So let us take a left hand side. What is there? That is A. So we can say that if X is belongs to A means obviously X element must be belongs to A union B. We know that what is the elements in A union B? The combination of set of elements in A as well as set of elements in B. Agree? So from the what we have given what is given as we know that A union B must be equals to A intersection B. Agree? So I'll be applying this property here. So from this what I can say? I can say that X belongs to A intersection B with the help of a what? Given statement here. So if X is an element which is in belongs to set A and set B, from this I can conclude that X must be belongs to B. Agree? So from this actually what I can say? X is element is in A, X element is in B. We can conclude that A is subset of B. Agree? For proving B is subset of A, now what I will do here? Now let us consider, I have taken X element now. So let us take a Y element A, which is in set B. If Y is in set B means obviously that Y element must be belongs to its A union B. Is it okay? We already know that. What is the property we know? A union B, they have given it as A intersection B. Not a property, this is a given statement. Agree? So this is given to us. So I'll be applying the same formula here. So what I can say? I can say that Y must be belongs to A intersection B. Agree? If Y is an element which is there in the intersection means obviously Y must be belongs to set A. Right? From this what I can say? Y is an element which is in set B. Y is an element which is in set A. From this I can say that B is subset of A. Agree? Take this as the equation number 1 and take this as the equation number 2. So from this what I can say? Therefore A is subset of B and B is subset of A. With the help of equality of a sets, I can say that A must be equals to B. So when can I say A must be equals to B? If and only if A union B is equals to A intersection B. Agree? So I have taken one statement as a true, I have proved the other one, right? Now let us see the second step. What is the second step? Assuming that the other one will be, let me write it down, I'm sorry. So assuming that step number 2. What we need to assume? Let us consider given that A must be equals to B. Try to assume the second statement is true. What we need to prove? Now let us prove the first statement. To prove that, what we need to prove? Simply let us take to prove. What we can say here, it is given that A union B must be equals to A intersection B. This is what we need to prove. For proving this is sake, what I will do here, so let us consider the left hand side. Okay, so now let us consider. So let us consider that A union B. Agree? A union B must be equals to A intersection B. So if I take A union B, A union with in place of A, I'll be replacing with B, or in place of B, I'll be replacing with A. I can say that if I take A union B is equals to A union with what? Simply try to write it as a A. What is A union A? A union A is nothing but what? Simply A set again. So I'll be writing A here. Is it okay? Also, now let us consider, instead of let us take the left hand side separately, right hand side separately. Okay. So this is what we have taken for left hand side. Agree? So now consider the right hand side. What is there in our right hand side? Here we are having A intersection B, right? This is A intersection B. We know that B is nothing but A. So I'll write it as what? A intersection A. What is A intersection A? A intersection A will be what? Always A set. Agree. So from this, what I can say? I can say that Left hand side is equals to right hand side. We got. Agree. What is there in the left hand side? We are having left hand side is what? A union B is nothing but A intersection B. Agree? So when this is true if and only if A must be equals to B. So finally what I can conclude? We can conclude that A union B always is equals to B union A if, what is this? If means if and only if A must be equals to B. This is the statement. We need to prove it. Is it okay? Any doubts in this? If you have any doubts, you can ask. Okay. Thank you.